All right, so I'd like to talk a little bit about processes. There are three sort of types of process, and to list them out, we can run a quick PS awks, which will list a whole bunch of different processes they're running on the system. And here we see three main types of process. Let me just quickly pipe this into less so it's easier to get through. Three main types of processes. The first is probably what most people are used to, and that's just let's just ping. Whoops. And PSOX here we'll see bin bash ping quad 1, and that is called a shell job. A shell job is just any command that's started from the command line. So something like bin bash or ping or PSOX for at the very end there is going to fall under that category, and that's pretty common. The next type is what's called a daemon, and that is a process that provides services. So NTPD is my network time protocol daemon. Often these will end with D. So if you see HTTPD, SSHD, VSFTPD, just to throw in a bunch of acronyms, if you're unfamiliar, those are, it is just an HTTP server, an SSH server, a file transfer server, and the VSFTPD. But a daemon is a process that provides a service. What I have highlighted right here is NTP. That's consistent time. So that's my NTP daemon. The final type of process here is what's called a kernel thread. Now, these are important to monitor looking at these kernel threads, but you can't really manage them with the same tools. If you want to stop a kernel thread, you kind of have to bring down the whole system, more or less. So those are good to monitor, but in terms of actually editing them, it's a lot more difficult. But with these daemons, we'll edit them later with something called systemd, which is your system daemon. But right now I'd really like to focus on these right here, your shell jobs. Now, I've already kind of shown you how to view all of your services with PSOX. There are some other options, just PS, for example. This will list all of your services started by sort of your own user. There are a lot of flags you can do with it. EF will list tech E. E will select all processes, and then tech F, full format listing. As you can see, the man page, there's a whole lot of stuff here in the process command, but two of the most common is PSAUX, that will list all your processes, and then PSFAUX, it's FAX, I believe, yeah. Just had to double check. This will list sort of a process tree. So for example here, Alacrity is my terminal emulator. Bin bash is my scripting engine, and then PSFAX is the command I ran. So you could see a whole process tree there. A little bigger one, this is the CIT VPN. It's just sort of starting, you can just see how the process tree works there. So things that have no parent are going to be started by what's called systemd, which we'll go over later, and sort of the indented things here are a child process, which means it was just started by a different process. So this bin bash is a child of Alacrity, and PSFAX is a child of bin bash. We can also say bin bash is a parent of PSFAX because it spawned this process, it created this process, and Alacrity is a parent of bin bash. So that's sort of the PS command and looking at your processes. Let's go back to this example. By default, pings will run forever. And as we've said before, Control-C will kill it. But what if we want to just put it in the background for a little while? We can Control-Z to stop the process, and then in order to pull it back, we'd FG to foreground the backgrounded process. And as you can see here, it was on sequence 7, and then it goes to sequence 8. So it didn't restart the command, it simply paused and then regenerated it later. Now what if we do that with multiple commands? We see an interesting thing here. We see this 1+ and 2+. Now what we can do with this is, those are both still backgrounded commands, but what we can do with them is bring back them by number. So %2, for instance, will bring back this quad 8 ping, and we got that 2 from here, the number there. So if we start that up again, we background it. What we can do to list sort of all of these backgrounded jobs is we run this jobs command. And as we can see, we have 2 stopped jobs, and we can bring them back again with the foreground command %, and then the number of the one you want to bring back. So if we bring back both of them and kill them, we can see jobs is now empty. So that's sort of the basics of backgrounding and foregrounding commands. But what if we want to, we don't want to necessarily background a command, or let me move back a step. What if we want to put a command in the background, but we don't want to, but we want to do that like sort of at the beginning, so it doesn't take up the whole screen. So let's just, so this by default will ping quad 1 and send that to dev null, which will not return anything. Which, if for some reason we wanted to do this, would be great, but our command line is taken up. So what we do is we put an ampersand after it, and as you can see, we get the same syntax here. And then what we get here is a number. That number is the process ID. So if we go back to PSOX, we can see everything has a process ID. And that's how we uniquely identify our processes. And as we can see, ping is backgrounded, and we can see, but instead of being stopped here, it's actually running. So that ping is still going on now, and so that behavior is a little different than Control-Z, which stops the process. Now, in order to kill a process, you can type in kill and then the process ID. And let's kill this ping, which is 26990. Now if we run, if we run jobs again, we can see the process has been terminated. And if we look here, the PSOX has been killed. Well, how do we, because there's a lot of stuff in here, though. And what if we want to find things a little easier? One thing we can do is, of course, just use the standard grep for Alacrity, let's say. And that works pretty good. But there's also a sort of built-in command, pgrep, which will look through the processes, and then you can type in the name and it will give you the process ID of all of the instances. In my experience, I just prefer this way because it gives you, again, all of the information here. And I just think it looks nicer, but if you want a sort of just the PID, you can use the pgrep utility. And again, this tacl just gives you the process name, but since you're searching for it, you should know the process name already in most cases. Unless you do a partial string, then of course the process name might be helpful. For example, let's just look for everything with lib in it. Maybe that's just not enough. Alright, I'm not 100% sure why I didn't actually find these. Maybe I need a... No. So, ignore that. pgrep is a way you can find patterns in a through... it's a way you can look through the processes easier. That's what you can use for pgrep. Let's get back to our ping. Send that to dev null. Oops, and then background it. And then we can run psaux to see it's really down there. And then we can run what's called the kill command. Looking into it a little bit more, it says specifically it terminates a process. And what it can do is there are three sort of, this works with signals. There are three signals that are of primary importance to a system administrator. That is 15, 9, and 1. 15 is called sigterm. Let's see if it's in here. It's not. Alright, okay, so it's not in there, but sigterm is 15. That's the signal ID for sigterm, and then there's sigkill, which is equal to 9. And then there is sighup, which is equal to 1. And these three signals are probably the most common that will be used. Sigterm will terminate a process, and sigkill will also terminate a process, but they function slightly differently. Sigterm asks, sigkill says. So if you're using signal 15, what will happen is you'll tell a process, hey, it's time to stop. 9 won't do all of that. It'll just stop the process and it won't have a clean exit. 15 will give it a clean exit, 9 will not. So you should only use 9 if you, first if 15 doesn't work, and then if you're if killing the process is more important than sort of maintaining the data perfectly. What sighup will do is just hang up a process, and that can be useful when you need to reread configuration files for a process, because once you restart it, once that process restarts, it will reread its configuration files, and that way you can keep the process running and still regenerate these configuration files. To go over some of at least the sigkill, I'll do a quick demonstration. whoops. This is DD, the command, DD stands for data duplicator. And what that will do is basically, it's a fancy way to copy data. And it will move it from the input file dev0 to the output file dev null. And if you notice, this won't actually do anything. It's just a way to run a process. What is job 1? First, let's kill 27831. That's the process ID for ping. So we kill that, and then we can see here that's terminated. We run jobs again. This DD is the only one that's running. Let's just run this a few more times, and then we can psaux and see we have a couple DD commands. Another thing we can do is look at this through the top command, and here we can see our DD is running, data duplicator, and it sort of gives a process list that updates live based off. I think this is sorted by CPU utilization, but you can go through and do more of it on your, select more of it if you'd like. So, just looking at DD, we can see there are some extra stuff, but you know, our processes, again, are there. Over here, they're taking up a lot of resources because they're just humming away, copying nothing to nothing. What we can do is then change the priority of some of these DDs with what's called niceness in Linux. To do that on a running process, we use the renice command, tech n to change the niceness, and with niceness it works kind of weird. You can move from -20 to +19, and that will determine the priority of a process. Now, positive numbers are lower and negative numbers are higher. So N5 and then P, let's just pick here 28854. This will change the priority of it. So if we go back to top, we can see this DD with 5 is going to drop in the rankings of the utilization because it's being less, it's moving around a little bit right now. Maybe HTOP is similar, it's just a nicer format. It's moving around a little bit, but as you can see, it has dropped down to the bottom. And then we can, for example, -5, and then let's pick a process 28859, and we can see permission denied. So the reason why this is because to lower the niceness of a process, you don't need administrator permissions, but to raise the niceness, you do. So let's run a quick sudo bang bang, and we can see the new priority was set to -5 now, and we can see -5 is jumping sort of up in the rankings, and the niceness is able to determine what processes should be sort of prioritized over another. One word of warning, setting a niceness of -20 is the highest priority, but it's not generally advised because that can cause some issues where some important system files don't get loaded properly, and if you don't quite have that, you can sort of run into unexpected errors. So what we can do now is look at this sort of process tree, and let's just look for DD. And here we can see this is sort of everything that's been spawned by this terminal. We can see these are our backgrounded processes, and these are the processes that executed in the foreground. Now, we run into an interesting scenario where what if we kill, I'm going to need sudo for this, kill the terminal. What will happen is, of course, the terminal will close, but then what we can see is these dd commands are still running in the background. So what happened was, it's not that now dd is stopped, it's that it's no longer a child of the parent. So killing the parent does not necessarily kill all the children. So what we can do next is run a command called kill all, and this kill all will, kill all processes named dd. So when we do this, we can see we no longer have any of these dd processes. Now, it's generally advised to use kill over kill all, just because when you kill by process ID, you can be a lot more specific. Say you had, I don't know, something, what you can do is run into errors where if you don't pay close attention to what you're typing in, you're painting with too broad of a brush, and you can accidentally kill some processes you didn't necessarily mean to kill. But with just kill, what you do is you don't really run into that same situation. Now, there's one sort of final thing I want to talk about, and that's pkill. When we run pkill htop, for example, we see htop goes away. When we go back to that screen, htop is no longer running. And I don't know if I mentioned it before, but htop is just a nicer version of top, and that's a process viewer in Linux. You can think of it similar to Windows Task Manager. They have similar goals. But that's sort of the basics of processes, and yeah.